we'll start with the first topic, voltage series feedback amplifier. So here, this is a non-inverting amplifier. In that, what it consists of, this is a basic amplifier, this is a feedback network. So this is a feedback topology which already discussed in the module 3, where Vi is the input signal, Vi is the input signal, Vf is the feedback signal, Vs is the source signal, and V0 is the output signal. A is the gain of the basic amplifier, beta is the gain of the feedback network. So here, without feedback, the gain of the amplifier is V0 by Vi, that is A. With feedback, the gain of this amplifier is V0 by Vs. And at the input side, if I apply the KVL, it becomes Vs minus Vi minus Vf equals to 0. So you can say that from this Vi equals to Vs minus Vf, because this is a feedback network, is a negative feedback. Now, we'll move on to the equivalent circuit diagram here. That the same block diagram is replaced by its equivalent circuit. So here, the basic amplifier is replaced by an operational amplifier, where V1 and V2 are the input signals, V0 is the output signal, these two are the dual power supply. So here, VID is nothing but the difference of these two, V1 minus V2, because V1 is connected to the positive, V2 is connected to the negative. Now, Vf is a feedback signal. This is a feedback network connected from the output towards the input. It contains RF and R1, okay, where V0 is the input signal for this. So now, here from this circuit, if I apply the KVL also, we will get the same expression, Vin minus VID minus Vf equals to 0, or we can write that VID equals to Vn minus Vf. So applying KVL, or directly you can write, because this feedback is a negative feedback. So now from this we'll start the topics one by one. We'll derive the expression now. The first derivation for this is closed loop voltage gain. So to do that, from this circuit you can write here the open loop voltage gain can be written as A equals to V0 by VID without feedback. This is V0 by Vin, Vf equals to with feedback, that is closed loop voltage gain. This is the gain of the feedback circuit, Vf by V0, beta equals to Vf by V0. So 1, 2, 3, these are the three equations written just from this circuit. Next thing, so here the negative feedback, because I already explained the negative feedback importance is, if I apply the KVL at the input loop, minus Vn plus Vid plus Vf equals to 0, or we can write Vn minus Vid minus Vf equals to 0, both are same here. So we'll get this expression, Vid equals to Vn minus Vf, where Vid is the difference input voltage, Vn is the input voltage, Vf is the feedback voltage. Now from this we can say that the output and input voltages are in phase here. So here the mistake is written, just clarify this. So this is 180 degree out of phase is wrong here, okay. This is nothing but, we can write here in phase or 0 degree, okay. So that is a change you have to make here in the assignment which I have written. Now, first we will concentrate on the closed loop voltage gain here. We know that for the closed loop voltage gain from this circuit, V0 by Vn, that is AF equals to V0 by Vn, where AF is nothing but closed loop voltage gain from equation 1, equation, I think here it is 2. Now, where V0 is output voltage, Vn is the input voltage, AF is the closed loop voltage gain. From equation 1, that is this is the equation 1 here. From equation 1, A equals to V0 by Vid can be written as V0 equals to A into Vid, right? So now V0 equals to A into Vid is nothing but V1 minus V2 from the circuit diagram. Now we know that here from the circuit diagram, V1 is connected to the Vin, V2 is connected to the Vf. So you can replace V1 by Vin and V2 by Vf here. The same thing is done here. So here V1 is replaced by Vin, V2 is replaced by Vf, whereas Vf is written as V0 into Rf divided by R1 plus Rf. V0 into R1 divided by R1 plus Rf. Okay, so how it is written here from the feedback network. Now look at this feedback network here. V0 acts as the input, Rf and R1 are the resistors, Vf is the output voltage. So what we need is Vf here from the circuit. So this circuit can be redrawn like this also if you have doubts. Okay, So here I will draw this circuit in like this. So this is V0, this is RF, so this is R1, and this is connected to ground, and here this is nothing but plus to minus Vf. So this circuit is taken like this. Okay. So here if I is the current flows through this, now applying the KVL, so this is RF and this is R1. If I apply the KVL and simplify this, we will get Vf equals to, okay, V0 into R1 divided by R1 plus RF. Okay. If I apply the KVL and replace I by the equation. So that's why it is written here, Vf is directly equals to V0 into R1 divided by R1 plus RF, voltage divider circuit, if you remember that. Now we will substitute equation 6 and equation 5 in this equation. Okay. So 6 and 7 are substituted in equation 5. This equation is 5. What I will get is V0 equals to A into Vid is nothing but V1. V1 is nothing but V in here. V2 is nothing but V0 into R1 divided by R1 plus RF. This is written here. Then what I have to do here, multiply the value of A with this expression. We will get it as A into Vn minus A into V0 into R1 divided by R1 plus RF. So that can be shown in the next page here. So this page we have shown here V0 equals to multiplied term, which is just explained. Now from this, let's rearrange the equation. This you have to take to the LHS side. So it becomes V0 into bracket, because V0 is common here, 1 plus A into R1 divided by R1 plus RF equals to A into Vn. So what I need is closed loop voltage gain, that is AF. This I need, which is nothing but V0 by Vn. Now rearrange this equation. So this is V0, this is Vn. Take Vn to this side, it becomes V0 by Vn. Here A is left, so divided by 1 plus A into R1 divided by R1 plus RF. Take the LCM here, it becomes R1 plus RF into AR1 divided by R1 plus RF, which is written in this term here. So here A at the LCM, A at the numerator. So this term, multiplied term is RF R1 plus AR1 divided by R1 plus RF. Now this goes to again numerator, and you can write finally like this, A into R1 plus RF divided by RF into RF plus R1 plus AR1. Now we'll do some assumptions here. We know that typically the open loop gain of the amplifier is infinite. Here it is assumed that 10 raised to 6. So because, therefore you can write here, if AR1 means this term is much greater than RF plus R1, because A is very high. When A is very high, so here RF plus R1 becomes very smaller. Then this complete term is replaced by AR1. Okay. So this equation 8 becomes, so here A into bracket of R1 plus RF divided by AR1, because these two terms are cancelled, RF plus R1. Now A will get cancelled, we will get AF equals to 1 plus RF by R1, which is explained in the introduction part, that AF is nothing but 1 plus RF by R1. Using the practical circuit diagram or the circuit diagram, we have derived this one. Now the relation between this AF and beta can be obtained in the next explanation. Listen here. The gain of the voltage series feedback, that is non-inverting amplifier, is determined by R1 and RF. So we know that beta is nothing but what? Vf by V0. Vf is what? Here Vf is nothing but V0 into R1 plus divided by R1 plus RF. Now substitute that one here. So what I will get? V0 into R1 divided by R1 plus RF into V0. So V0 get cancelled here. So we will get R1 divided by R1 plus RF, right? So we can say that beta is nothing but V0 by Vf is nothing but this much. R1 divided by R1 plus RF is nothing but what? 1 by AF here, right? So if I take the LCM here, R1 plus RF by R1, take the reciprocal, it becomes R1 divided by RF plus R1. Both are same here, okay? So otherwise shown here. So now we can say that beta is inversely proportional to the closed loop voltage gain. This is another relation. The next thing here is, we can also express the closed loop voltage gain AF in terms of A and beta, which is as follows here. So now look at this. So we know that here AF is nothing but A into R1 plus RF divided by RF plus R1 plus AR1. So this expression is taken here. Okay. So now dividing numerator and denominator by R1 plus RF. If I divide this both numerator and denominator, what I will get? This term, and this term R1 plus RF get cancelled. In the numerator left with A. In the denominator we have left with RF plus R1 plus AR1 divided by this one. Okay. Now this is rearranged like this. AF is nothing but AF divided by 1 plus AR1 divided by R1 plus RF, because here this R1 plus RF, if I separate them with a plus sign, these two will get cancelled. What I will get is 1 plus, okay, A into bracket of R1 plus RF. This term will be cancelled, will get. So now we know that R1 divided by R1 plus RF is nothing but beta. Here we already proved that one. So here R1 divided by R1 plus RF is nothing but beta here. So that is placed here. So what I will get? So here what I will get? This place AF becomes A divided by 1 plus A beta. So this is also shown in the block diagram. So this is about the derivation of closed loop voltage gain. Okay, just go through these ones, we'll understand. So this is just a difference input voltage, ideally 0. This is not important. Just for understanding purpose it is written here. Our main intention is to derivation about closed loop voltage gain up to this much. Okay. So if you have any doubts, text me, we'll clarify that one. Thank you.